Hi everyone. In today's session, we are going to discuss one another important topic of discrete mathematics, which is congruence relation. A congruence relation is a tool or mathematical tool which is widely used in many domains like computer science, AI, ML, especially when we are dealing with the security systems. It is used in encryption and decryption of some messages. It is used to code or decode some messages, and there are further other applications also. In today's session, I am planning to give you introduction, the overview of a congruence relation, that how exactly a congruence relation looks like, then what is a linear congruence? And at last, I am planning to take some example to explain you that how we can find the solution of a linear congruence. So let us start it. A congruence means what? If we are having two integers a and b, and m is some positive integer, then a is said to be congruent to b. In modulo m, if a minus b is a multiple of m, the same can be said in this manner that a minus b is divisible by m. A minus b is divisible by m, or we can say a minus b is a multiple of m. If this holds, then we say that a and b are congruent to each other in modulo m. It can also be said is in this manner that A and B are said to be congruent to each other in modulo M if both of them give the same remainder when divided by the number M. Means the number A and B is congruent or said to be congruent if when they are divided by M, they give the same remainder. They gives the same remainder. For example, so if suppose that I am taking some number a as let it be 11 and some number b let it be 15. One number is 11, one number is 15, and I am taking m equals to 2. So can I say a and b are congruent in mod 2? This can be verified or checked by using the definition. The definition says that when A and B give the same remainder when divided by m, then they are congruent to each other. So, what is the remainder when 11 divided by 2? When 11 divided by 2, in this case, the remainder is 1. Over here, when the 15 divided by 2, the remainder is also 1. So here you can see 11 and 15 giving the same remainder in modulo 2. Hence, they are called as congruent to each other. And this is how we write it. A congruent to B in mod 2. It does not matter. Firstly, I am writing A or B because the same can also be written as 15 is congruent to 11 in mod of 2. Okay, so this is how we can understand that what exactly we mean by a congruent relation. In place of m equals to 2, if suppose that I take m equals to let it be 5. So in case m equals to 5, what is the remainder when 11 divided by 5? The remainder is 1. But the remainder when 15 divided by 5 is 0. Both of them giving the different remainder. So we will say in mod 5, they are not congruent to each other. And we will write it like this: 15 is not congruent to 11 in mod of 5. Okay, so this is how we can understand the definition of a congruence. Congruence, this is the three parallel lines is used to denote congruence relation. If not, we will cross it. Okay, so this is how we can understand the congruence relation. There's one more definition that we do have for this congruence. Let us see that also. What it says as A said to be congruent to B in mod M if A minus B is divisible by M, which is also covered in the first definition when A minus B is divisible by M. If I take earlier example like 15 and 11 in mod, 15 and 11 in mod 2, so 15 minus 11 is 4 and 4 is divisible by 2. When we are talking about divisibility over here, we mean that complete divisibility. Like uh, 10 is completely divisible by 2, but 11 is not completely divisible by 2. Okay, so here the divisibility means the complete divisibility. Symbolically, it is expressed as if A and B congruent to each other is in mod M, then in that case, this is how we express or we write this expression. A congruent to B mod M. As just a common sense based thing, it does not matter like whether I'm writing A congruent to B or I'm writing B congruent to A in mod M. Both is having the same sense. This is also saying that A and B are congruent to each other, and this is also implying that A and B are congruent to each other in mod M. Let us proceed further. Now, let us try to understand what we mean by a linear congruence. So, a linear congruence is a type of congruence which is having a variable in linear power. That means a congruence of the form AX congruent to B mod M is called as a linear congruence. What the additional point comes over here, this X additional comes over here. If in place of x, we are taking variable in power 2, we call it as a quadratic congruence relation. In the same manner, if it is power 3, we call it as a cubic congruence relation. So, just the name linear, quadratic, or cubic is indicating that what is the degree of the variable which is involved in the congruence. Now, if I'm talking about the solution of this congruence, what we mean, any integer values of x, we are talking about integer, do remember, any integer value of x which satisfy this congruence is called the solution of congruence. Any integer value of x which satisfy means what? The same as we use in the definition. So any value of x which satisfies this equation means what? When you put x something over here, then your ax minus b must be divisible by m. The definition, it can also be written as m is m divide ax minus b. This is not upon, this is used for the sign divisibility, a vertical line. Okay. So we will say this equation satisfy if m divide ax minus b, which is same thing as ax minus b upon m gives you some integer. It's the same thing, ax minus b upon n gives you the same integer. Okay, so this is how we understand about a linear congruence and its solution. Do remember, we are only concentrating on integer solution. So this x can't be a number which is not an integer. Huh? So our domain for the solution is only the integer values. So AX congruent to B mod M can also be written as M divides AX minus B, which is same as AX minus B upon M equals to some integer I. Or we can say take some integer T. So if I simplify this equation, I can write it as AX minus B equals to M times T. From here, x is equals to m times t plus b upon a. What is t over here? T belongs to set of integer where t is some integer. So this is how we can find the solution of this linear congruence. That means those value of x we are searching which satisfy this given equation, and how to obtain those x, that x is the value of m times t plus b upon a, where t is some integer. So that means we are taking some integer value t, put it over here in this expression. Once this whole expression becomes as an integer, that x is your solution. That means we are searching some t which make this expression for x as an integer, and that x we call as the solution of this linear congruence. Okay, this is one of the way to get the solution of a linear congruence. Another way is what we can find it by hit and trial or totally in the random nature. For example, suppose that someone is asking find the solution of the congruence 2x is congruent to let it be 5, 2x congruent to let it be 4 in mod of let us take it as 6. So I have taken one linear congruence, which is 2x congruent to 4 mod 6. And I'm interested to find its solution. I'm interested in to find the solution of this equation. So let us see how we can get it. So if I put x equal to 1 in this equation, so this is what 2 congruent to 4 mod 6. Is it satisfying the condition? No, because like either we can take the first definition which says that A and B must give the same remainder. What is the remainder when 2 divided by 6? 2 itself. What is the remainder when 4 divided by 6? 4 itself. So the remainder is not same, so they are not congruent. So when I put x equal to 1, this linear congruence is not satisfied. So I will say x equal to 1 is not a solution of this congruence. On the same side, if I take one more value, let us see x equal to 2. If I put x equal to 2 in this equation, then how it looks like 2 cross 2 congruent to 4 mod of 6. 4 congruent to 4 mod of 6. Is it correct? Yes. The remainder when 4 divided by 6 itself, the remainder when 4 divided by itself is 4. So yes, the same remainder is obtained. So I can say x equals to 2 is the solution of this linear congruence. So I can say x equals to 2 is the solution of this linear congruence. So this is one way which is totally based on random selecting the values of x with satisfying the equation. This is what involving some mathematical calculation to get the solution of a linear congruence. One more method is there which is based on the inverse concept of a congruence. We will discuss that later on. Now let us take few more examples. So example number 1 is what? 3x congruent to 2 mod 8. We are supposed to find the solution of this congruence. I'm going to use the definition which says that if ax is congruent to b mod m, then it means m divide ax minus b. So the same can be written as 8 divide 3x minus 2, which means what? I can write it as 3x minus 2 upon 8 is some integer, or I can say is equals to 8 times t for some integers t. So from here I can get the value of x, which is 8 times t plus 2 upon 3. Now I'm supposed to put the value of t on this in this equation so that x comes out as integer. So what happens if I put t equals to 0? So x comes out as 2 upon 3, which is not an integer. So we can't consider this as a solution. In the same manner, if I put t equals to 1, it will be 10 upon 3, so not an integer. T equal to, let us take t equals to 2 if I put t equals to 2, what I will get, x is equals to 8 to 16 to 18 upon 3, which gives you 6 as an integer. So x equals to 6 is the solution of this linear congruence. Quite simple. Okay, write it as m divide ax minus b. Simplify, substitute some t which make x as an integer. Now the question is what? One more question is there that how many x we needed as a solution, which is related to how many solution this congruence will have. Like suppose that I just get x equal to 6 and stopped it. This is one of the solution. But it may possible that this congruence is having more than one solution. So that we will also discuss that how exactly comes to know that how many solution is there for a linear congruence. Okay. In this case, it is having only one solution, which is x equal to 6. Let us take one more example. 4x is congruent to 5 mod 9. So for this situation, let us write in the same manner. So what I should write? 9 divides 4x minus 5, which means that 4x minus 5 is equals to 9 times some t, where t belongs to set of integers. It may be positive or negative, okay? Here t can take any value. Only the condition is what? X should be an integer. Any integer value of t which make x as an integer, okay? So x is equals to 9 times t plus 5 upon 4. So what should I put for t so that this x comes out as an integer? This x comes out as an integer. So if I put t equal to 0, then 9, 5 upon 4 not an integer. T equal to 1, t equals to 2. So 18 plus 5 not a solution. I think at t equal to 3 it will work. So x is equals to 9 cross 3 plus 5 upon 4. 27 plus 5, 32 upon 4, that is 8. So x equals to 8 is the solution of the given equation. Do remember one thing, t is not a solution. What is the solution? The values of x. Because the question is asking the value of x. They're not asking the thing which is t. We introduce t by ourselves so that we can get the values of x. Okay. Let us take one more example. 18x congruence to 30 mod 42. 18x congruence to mod 30, 18x congruent to 30 mod 42. And I think one more example is there. 3x congruent to 7 mod 11. Okay, so if I'm talking about, I will discuss the last one first. 3x minus 1 congruent to 7 mod 11. 7 mod 11. So it means what? And let me just put some line on it. Okay. So 3x minus 4 mod 7. So that means if firstly, I need to write it in the standard form. It is not the standard form of a linear congruence. The standard form is what? Ax minus Ax is congruent to B mod n. This 4 is additional. So by using the congruence property, which says that we can add any integer on both sides of an equation. So I'm adding 4 on both sides. So it will looks like 3x congruent to 4 minus plus 4, 0, 7 plus 4, 11. So this is how this equation looks like. What I did, adding this 4 on both the sides. Or which is the same thing, they taking this 4 on this side. Now it is the same as the earlier congruence that we are having. So the same can be written as 11 divide 3x minus 11, which is same as 3x minus 11 equals to some t. X is equals to what I did, 3x minus 11 equals to, this is 11 times, yeah. So x is equals to 11 times t plus 11 upon 3. I'm getting this step, which is the same thing. If m divide ax minus b, that means ax minus b upon m is some integer t. So just simplify this thing. Now we are supposed to get those values which make x as an integer. So if I put t equal to 0, it is 11 upon 3. If I put t equal to 1, if I put t equal to 1, this equation, in this case, it is also 22 upon 3. If I put t equal to minus 1, we can put t any integer, okay? T equal to minus 1, x comes out as 0. And 0 is an integer, yes. So this is how we can get the solution of this equation. So this equation is having x equal to 0 as a solution. X equal to 0 is the solution of this equation. Okay, so this is how we can find the solution of the linear congruences. Uh, Part number 3 is also left. Let us discuss that too. Let us discuss that too. So, so let us talk about this example. So which is 18x, 18x congruent to 30 mod 42. The same can be done as the earlier manner, which is 42 divides 18x minus 30, which can be written further as 18x minus 30 equals to 42t. From here, x is congruent or equals to, not congruent, equals to 42t plus 30 upon 18 for some t which is integer. So we are supposed to put the value of t in this equation, and whichever satisfies this equation is the solution of the linear congruence. Is the solution of linear congruence. For example, if I put t is equals to minus 1, so this will comes out as 42. So 42 minus 42 plus 30, 12 upon 18. No, it's not satisfied. T equals to 1. So 42 plus 30 is 72 upon 80. So 4. I get x equals to 4 as a solution. I get x equals to 4 as a solution. Now, the thing is that, which I will cover in the next session, should I stop over here or should I go for some other solution? Now, how one should comes to know that this equation is having only one solution, two solution, infinite solution, no solution, that is also important to know because it many time comes as find all the solutions of this linear congruence. Okay, so I'm going to cover that in the next session. For just now, this is x equal to 4 is one of the solution. I suggest you, all of you, to try to find some other solution for this recurrence relation. Okay, so I hope you understand the concept of linear congruence, how one can find the solution of a linear congruence. Okay, now let us close the session. I hope you understand the things. So now, thank you. Going to stop this session.